So in this video, I'm going to continue talking about inverse functions, and specifically, I want to define what the inverse of a function is, and I want to be able to verify that two functions are indeed inverses of each other. So I want to start off by defining what an inverse is. The inverse, which is written f with a little -1 in the corner of x, is the inverse of f of x if and only if two things happen. First and foremost, if I take f inverse of f of x, as in I take the original function and I plug it in to its inverse, we should actually get x. The same thing should happen if I do it the other way around. So if I take f and I plug in the inverse f inverse of x, I should also get x. So no matter which way I do it, I should always get the same answer, and it's the original x value. That means essentially they undo each other. That means, for example, I'll talk about it this way. If I have x plus 4 as one function, as in I take my x value and I add 4 to it, its inverse should do the exact opposite, should subtract 4 from it. And the thought process is if I plug in one of these into the other, and I'll do that in blue, if I take x minus 4 and I plug it into x plus 4, those 4's will cancel and I'll just get x. Same idea if I do it backwards. If I take x plus 4 and I plug it into x minus 4, those two 4's will cancel and I'll just get x. So that's the idea. Function does one operation, the inverse will undo that operation. Another way to talk about this is that for every member A in the domain such that f of A equals B, then f inverse of B will take it back to A. Again, it's taking my x values and turning them into y values for the original function. What the inverse function will do is it'll take those y values and turn them back into x values. It's important to recognize a relationship. So when does a function have an inverse? Well, a function does have a unique inverse, one function that is its inverse, if and only if the function is 1 to 1. That means the inverse is not only just one function, but so is the original function. They match up, they go together, they're related to each other. It's a nice, clear relationship between them as long as the original function is 1 to 1. And that's also going to imply that the inverse is going to be 1 to 1 as well. I do want to point out a couple of things that are important as well here. There is a common notation mistake that people get mixed up in here. Recognize that x to the -1 is written as 1 over x. That negative exponent tells me to move it to the bottom, and it's now an exponent of +1. However, this is not going to be true of saying that it's 1 over f of x. This -1 is not an exponent. It's just simply a notation marking inverse, just as much as this is technically marking the multiplicative inverse. But please do not get them confused that, that -1 up there with the f is not talking about an exponent, whereas with the x by itself, it is talking about being an exponent. So let me go ahead and move on to some examples. So the first example that I have is I want to fill in the table of values. And let me just again highlight the fact that what the original function does is it takes x values and turns them into y values. That's the original function. What the inverse function is going to do is it's going to take those y values and turn them back into x values. So let me point out this first one. The first point that I have is -9, 2. And that's in my original function. So I'll write x and f of x, -9 and 2. So what the inverse will do is it'll take in the 2 value and spit out a 9, or excuse me, a -9. So 2, -9. So what I'm going to look at here is I've got x value of 2. That means the f inverse value is going to be -9. Okay. So that handles that first point. Let me go ahead and look at the next one down that I see. I've got 4, -9. So that's going to be important information. Again, 4 is the x value, 9 is f of x. Excuse me, -9. I apologize. So what that means is the inverse is going to undo this. So it's going to take in the -9 and spit out a 4. So that means here where x is -9, f inverse's value is going to be 4. All right. Let's try using an F inverse value. So the next one I'm going to use is this 4 and this 8. Now notice again, this 4 is my x value. F inverse is 8. So f of x is going to do the opposite. It's going to take the 8 and turn it into a 4. 8, 4. So that means here, where x is 8, f of x should be 4. Okay. All right, let's see about the last couple of answers we've got. We got 2 more blanks. So I'm going to kind of skip over this one because it's an x value. I don't know what that is. We'll come back to it. What I'm going to go ahead and look at now is I've already kind of filled in the 8 and the 4. I've already used that. We haven't done this 8 and 7. Now notice again that 8 is an x value and that 7 is an f inverse value. So my original function will switch them so that 7 will turn into an 8. Now I want you to notice here, in this case, f of x is 8, which happens right here, and x has to be 7. So that's going to be that answer. That's going to be that x value. Which tells me my last answer choice is going to be that 7 and 2. So let me write that down. X value of 7, f inverse is 2. So I'm going to switch those around and have 2 comma 7. So that tells me at x equals 2, f of x is 7. So there's that table completely filled in. So notice it was kind of important to pay attention to which values are what and try to fill it in using this idea of swapping x's and y's. Question 2 says, show that the functions f of x, which is 3 minus x over 4, and g of x, which is 3 minus 4x, are inverses of each other. So let me repeat again. The process that I want to do is I want to take one of them and plug it into the other, and then I want to switch it. So I'm going to do f of g of x. So that means I'm going to take g of x, which is this function, and plug it into the other. So let me write that down. I'm going to do 3 minus whatever that g of x function is over 4. So let me write that, 3 minus 4x. And I'm going to try to simplify this as much as possible and see what happens. So first and foremost, I notice this negative that I need to distribute. So we'll have 3 minus 3 plus 4x. 3 minus 3 is going to cancel. That's going to give me 0, leaving me with 4x over 4. Now 4 divided by 4 gives me 1, so that's going to be 1x left over. So that one checks out. The other thing that I need to do is switch them. So I need to take g of x and I need to plug in f of x. Now I will point out you do want to check both of them because there are some situations where I plug into one, get the right answer, but I plug into the other and it gives me the example I'll talk about is the plus or minus from the first video. So that's something to watch out for, is sometimes they don't come out exactly the same. So do always check both. So in this situation, I'm going to take this f of x and I'm going to plug it in to the other equation. So 3 minus 4 times f of x function, which is 3 minus x over 4. So first and foremost, one of the things that I'm going to do is I'm going to multiply by negative 4. I need to distribute that in here. And so I'll write that down. That's going to give me 3 plus, and that's negative 4 times 3 gives me negative 12. Excuse me. Negative 4 times negative x gives me positive 4x all over 4. Now I'm going to go ahead and divide this stuff in the fraction by 4. So that's going to give me negative 12 divided by 4 is negative 3, and 4x divided by 4 gives me 1x. And the last thing I'm going to cancel out is that 3 minus 3, which is going to give me 0 plus x, which is just x. So that one also checks out. So at this point, I do recognize that these two functions, f of x and g of x, are in fact inverses. So this does check out. Last one, number 3, show that the function f of x equals x over x minus 1 is its own inverse. Now, there are a few functions that do that where it is its own inverse. They are opposites of each other. So it's just important to keep in mind that that does happen sometimes. So what I'm going to do is I'm going to take f of x and I'm going to plug itself in. So I'm going to take this x over x minus 1 and I'm going to plug it into itself. Now notice, since there's two x's, I'm going to have to plug them in both places. So I'm going to do this. The numerator is going to be x over x minus 1. The denominator is going to be x over x minus 1 minus 1. So again, I'm plugging the function in for itself in the top, and I'm plugging the function in for itself in the bottom as well. So a couple things are going to need to happen. The first and foremost is probably going to be making a common denominator. So in the numerator, I don't really have to do a whole lot. But in the bottom, I need to do x over x minus 1 minus, and again, I'm trying to make a common denominator, so that 1 is going to turn into x minus 1 over x minus 1. So a couple of things are going to happen. Number one, I need to distribute that negative. So I'm going to keep x over x minus 1 in my numerator over um, x minus x plus 1 over x minus 1 in the denominator. Those two x's will cancel out. That gives me 0 plus 1, which is just 1. So I'm going to have x over x minus 1 all over 1 over x minus 1. You can call it keep, change, flip, but at this point, since I'm dividing by fractions, what I need to do is I need to flip the denominator and multiply. So I'm going to write this down over here, and I'll do it in blue. So I've got x over x minus 1, which was my numerator, times the reciprocal of the denominator, which was x minus 1 over 1. Now, since I have an x minus 1 in the bottom here and in the top here, they'll cancel, leaving me with x divided by 1, which is just x. Since I got x as the final answer, I know that this is its own inverse, and I don't have to check the other one because I'd just be doing the same thing. I would be plugging f of x into itself again. So luckily for us, we only had to do it one time, and it still worked out nicely. So hopefully this helps you guys better understand the concept of inverses, and I'll be back next time to talk a little bit more about them.